This is number 26 from the Newton's Laws Practice College Physics 12 handout. It's an elevator problem, but it's not about the person in the elevator, it's about the elevator itself. So we're talking about tension, because this is about the elevator itself. The first thing I'm always going to do is draw a diagram. Here's my diagram. It shows the tension and the weight. There's always weight down no matter what. There's no sideways forces, because this is not on a surface, so there's no sideways forces. There are vertical forces. The tension holds it up, and the weight is pulling it down. These are not equal because it's accelerating. But the question is, which one's greater? That's the key question. I had to do a quick calculation to figure out which one was greater. I know that the tension is 4,100 newtons, but I didn't know the weight. So I plugged into force weight equals mg. M is the mass, 450 kilograms. G is always 9.8. Comes out to 4,410 newtons. So now I know that the weight is greater than the tension. So immediately I know this is accelerating down. It doesn't mean it's in free fall. Then it would be, if it were in free fall, it would be accelerating at 9.8 meters per second squared. It's not in free fall, but it just happens to be accelerating down. To figure out that acceleration, now I look at sigma f equals ma. And you can also write f net equals ma if you want. You can write, instead of this, you can write f net equals ma. Sorry about the writing looks a little funky, by the way, because I'm doing this on a writing tablet at home. F net just means look at all the forces, so I do tension minus force W. Now some of you might be wondering, well, why do you do tension minus force W? Shouldn't you do force W minus tension? The answer is very simple. I always do up minus down, the positive minus the negative, no matter what. And I always do positive to the right minus negative to the left. And that way everything stays consistent. You'll see what happens next. If I put in these forces, 4,100 minus 4,410 equals 450A. So all I've done in between this step and this step, all I've done is plug numbers in. Then you can see that my acceleration comes out negative because of the sign convention that I use, tension minus weight. And I get negative 0.689 meters per second squared. So quick summary. I didn't know that the tension was less than the weight until I calculated the weight, so I did a quick weight calculation right here. This is my quick weight calculation. Then I did the usual F equals ma, but it's a sigma F, which means look at all the forces. Tension minus weight, plug in, and you get the acceleration. Now, this is the step that most people neglect. Most people don't like to do this step. People just forget about it, or they think it wasn't necessary. In other problems, like number 27, you have to do that. You have to write the whole thing out, and it'll be normal force here in number 27 instead of tension, because you're solving for the normal force. So you do normal force minus weight equals ma. It's that simple.